Welcome viewers. In this video, we will see the solved problem based on the types of DC generator. This part 4. Subscribe the channel for more videos. The soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the first problem. The resistance of the field circuit of a shunt excited DC generator is 200 ohm. So this problem based on the shunt DC generator. The output of the generator is 100 kilowatt and the terminal voltage is 500 voltage. So the output power and output voltage is given. The generated EMF is 525 voltage. This is our EMF generator inside the armature. So based on the data, we need to calculate armature resistance, the value of generated EMF when the output of 60 kilowatt and the terminal voltage is 520 voltage. Right? The first question armature resistance. The second question we need to find the generated EMF for a 60 kilowatt. Already it is given as the power is given 100 kilowatt. Now it is changed to 60 kilowatt and the terminal voltage will be 520. For that we need to find what is the generated EMF. Now we will see the given data. So the RS sketch shunt field resistance is given 200 ohm. The power output power is 100 kilowatt, that is 100 into 10 to the power 3 watts. So kilowatt means 10 to the power 3. The terminal voltage is 500 voltage, generated EMF equal to 525 voltage. Now the first part we will go for the armature resistance. We will find the armature resistance. So we know that EG shunt resistance EG equal to V plus IA RA. It's a basic formula for shunt generator, right? Now we'll find the load current IL. IL equal to P divided by V, power divided by voltage. Both are available. Output power and terminal voltage is given 100 kilowatt, that is 100 into 10 to the power divided by 500. Voltage is 500. So that is equal to 200 ampere. So the load current equal to 200 ampere. Then shunt current, shunt field current ISH equal to V divided by RSH. Because the shunt field is connected across the load. So the load voltage can be used for finding the shunt current. All are connected in parallel. Armature, field, load all are connected in parallel. So the same voltage can be used for finding the ISH. So V equal to 500 divided by RSH is given 200 ohm. So that is equal to 2.5 ampere. The shunt field current equal to 2.5 ampere. Now we'll find the IA, armature current. IA equal to IL plus ISH. In case of shunt generator, the current generated from the armature is IA, that is splitted into IL and ISH. Current flowing through the load as well as current flowing through the shunt field, that is divided. So sum of these two is the IA. So 200 plus 2.5 will give 202.5 ampere. So the current flowing from the armature is 205.5 ampere. Now we need to find the RA. So from this formula EG equal to V plus IA RA. From that RA can be written as EG minus V divided by IA. It is simplified, rearranged. So that the EG value is, we know the EG value, it is 525 voltage. The terminal voltage is 500. This IA is 202.5. Just now we calculated IA. So by simplifying this, what got 0.1234 ohm. The armature resistance is 0.1234 ohm. Now we'll go to the second part. The second part we need to find the generated EMF when the power is 60 kilowatt and the terminal voltage is 520 voltage. Right? For these two data we need to find what is the generated EMF. Right? So again we'll find what is the load current. Now the power and voltage is changed. So IL equal to P divided by V. 60 kilowatt, 60 into 10 to the power 3 divided by 520. So 115.3846 ampere. Right? So the shunt field current ISH equal to V divided by RSH. So the now V is 520 divided by 200 is 2.6 ampere. Right? For this given power and voltage we calculated the load current and shunt field current. So the armature current IA is nothing but IL plus ISH. Because of shunt generator, the sum of these two is the IA. So these two we calculated 115.3846 plus 2.6. So the sum of these two is 117.9846 ampere, right? Now again we are using the basic formula Eg equal to V plus Ia Ra, right? So here Vg we need to find, V is given 520 voltage. Ia just now we calculated 117.9846 into Ra is 0.1234, that is we calculated in the earlier, the previous case, same value we are using, right? So by simplifying this we got 534.55 voltage, so which is greater than the load terminal voltage, right? So from this the armature drop will be there, balance will be available as a low terminal voltage, 534.55 voltage, right? Now we calculated the generated EMF. We will go to the second problem. A 4-pole DC sun generator with a wave wound armature having 390 conductors has to supply a load of 500 lamp, each of 100 watts at 250 voltage, right? This is a sun generator, 4 poles available, 390 conductors are available. The voltage is 250, the load is 500 lamps available with each of 100 watts. Allowing 100 voltage for the voltage drop in the connecting leads. There is a 100 voltage, 10 voltage drop in the connecting lead between the generator and load. Brush drop of 2 voltage. There is a brush drop is 2 voltage is available. Calculate the speed at which the generator should be driven. We need to find the speed of the generator. The flux per pole is 20 milliweber. Then armature resistance is 0.05 ohm, sun field resistance is 65 ohm. So these are all the data given. We will see the data one by one. The number of pole equal to 4. The number of pole given in this generator is 4. This wave winding is given. So that number of parallel path is equal to 2. For wave winding, the number of parallel path is always 2. Then the number of conductor is 390. Voltage is 250 voltage. The flux is 20 milliweber, that is 20 into 10 to the power minus 3 weber. Milli means 10 to the power minus 3. Then armature resistance 0.05 ohm. Sun field resistance 65 ohm. The total brush drop equal to 2 voltage. The given is the total brush drop. There are 2 brushes available, so totally there is a 2 voltage drop including 2 brushes. The drop in the lead is 10 voltage. Right, one more drop is drop in the lead. Then we need to find the power. How will you find the power? There are 500 lamp available, each 100 watts. So 500 into 100 will give the total power, 5000 watts. There are 500 lamp, each of 100 watts. So 500 into 100 will give the 5000 watts. So the load in the output power equal to 500 into 100 equal to 50,000 watts. That is 50 kilowatt. Not 5,000, it is 50,000. So from that we can find the load current P divided by V. 50,000 divided by 250 will give 200 ampere. The load current is 200 ampere. Now we will find the ISH. ISH equal to V plus voltage drop across lead divided by RSH. This V is available 250, the drop across the lead is 10 and RSH is given 65. So simplifying this we got 4 ampere. So the load current is 200 ampere, the sun field current is 4 ampere. So from that we can find the armature current IA equal to IL plus ISH. In case of sun generator, this IA is split into IL and ISH, right? So 200 plus 4 equal to 204 ampere. The armature current is 204 ampere. Now from that we can find the generated EMF. Finally we need to find the speed of the generator. Generated EMF equal to E equal to V plus IaRa plus brush drop plus lead drop. Right? The generated voltage is converted into terminal voltage, armature resistance, brush drop and lead drop. So 250 plus the Ia we calculated 204 into Ra is 0.05, the brush drop is 2 voltage, the lead drop is given as 10 voltage. So by adding this we got 272.2 voltage. The generated EMF is 272 point voltage. Now we need to find the speed of the generator. For a generated EMF, one more formula is available in relating the speed. Pi n Z divided by 60 into P by A. The flux, number of conductors, speed divided by 60 into number of pole divided by number of parallel path. So by rearranging this, we can write n equal to, you have to multiply this 60 into A in the numerator. This pi Zp is brought into denominator, so that n equal to E into 60 into A divided by P pi Z, right? All these values are known. So E equal to 272.2. So just now we calculated, into 60 into A, number of parallel path equal to 2 because of wave winding, divided by number of pole is 4. The pi is given as 20 milliweber, 20 into 10 to the power minus 3. Number of conductor is 390. So by simplifying, we got 1046.92 RPM. The speed of the generator is around 1046.92 RPM. So in this problem, we discuss about the DC sun generator, problem based on the DC sun generator. Subscribe the channel for more videos. The soft copy of this material available in the drive. The link is given in the description box. Thank you.